Welcome back, guys. Today's video is on factors. We'll begin by understanding the meaning of factors, and then we'll learn how to find factors of given numbers. Let's begin. Factors are exact divisors. In other words, factors of a given number are those numbers that can divide the given number without a remainder. Now, what does this mean? Take, for instance, the number 12. If I decide to divide 12 by 2, I'm going to get 6 with no remainder. This means that 2 is a factor of 12 because 2 is an exact divisor of 12, and 12 divided by 2 leaves no remainder. However, if I decide to divide 12 by, say, 5, 12 divided by 5 is going to be 2 remainder 2. It means that 5 is not an exact divisor of 12. Therefore, 5 is not a factor of 12. I hope that makes sense. So here are two things that we need to know before we go ahead to list factors of numbers or to find factors of numbers. One is a factor of every number, and every number is a factor of itself. Take, for example, 12 that we have been dealing with here. I can say 12 divided by 1, it will give me 12, no remainder. And 12 divided by 12 will give me 1. So 1 is a factor of every number, and every number is a factor of itself. So those are two things that you should note. Now, next, we're going to go ahead and learn how to find factors of given numbers. There are different methods, different techniques that people use when they want to list factors of given numbers, but I, for one, this is how I like to go about it because this method helps you to be able to completely list all the factors, because there are some other methods where you use them, you will get factors, but you might not get them all. However, I like to do this. This is called expressing a number as a product of two factors. If you use this method, you do it correctly, you'd be able to find all the factors. So here is what I like to do. I like to break down the number as product of its factors, starting from 1. Because we know that 1 is a factor of every number, I can express 48 as 1 times 48. And then I'm just going to keep going with other factors until I exhaust it. After 1, the next number is 2. I know I can express 48 as 2 times 24. Now, if this is not something you can do, you can just try out your numbers on the side. For instance, now I know that 48 divided by 2 will give me 24. 4 divided by 2 is 2, and 8 divided by 2 is 4. So 2 times 24. I'm going to write that. Next, I'm going to try 3. I'm just using regular count numbers 1, 2, and 3. I know that 48 is 3 times 16. And if you didn't already know that, like I said, it's okay to come to the side and do 48 divided by 3, and you're going to get 16. Next counting number, 4. I'm going to try that. I know that 4 times 12 will give me 48. And if you're not sure of that, it's okay. Just try. 48 divided by 4 will give you 12. Next, I'm going to try 5. If you already know your factors, you're not going to try 5 because we already know 5 is not a factor, but if this is all new to you, you can go ahead and just try on the side. 48 divided by 5. If you try this, you're going to get 9 remainder 3. Because of this remainder, it means that 5 is not a factor of 48, and we're not going to use that. So next we're going to try 6. After 5 is 6. Again, if you try 48 divided by 6, it's going to give you 8. So you know that 6 is the factor, and that you can express this as 6 times 8. And after 6, try 7. 48 divided by 7. That's going to give you 6 remainder 6. Because there's a remainder here, you know that 7 is not a factor. And after 7, the next number we have is 8. But we already have 8 here. If I go ahead to write 8, it's going to be 8 times 6, which is going to be a repetition of 6 times 8, because of course you know that multiplication is the same either way. 6 times 8, 8 times 6 is the same thing. So there's no point repeating 8 times 6. So at this point, I'm going to stop. And then I would say, so therefore, factors of 48 are, and then I'm going to make a list of the factors. So from this side, I'm going to write it from up to down. And for these ones, I'm going to write it from down to up. So I'll have 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48. These are the factors of 48. Now, factors are definite. They're not like multiples. Remember when we were doing our lesson with multiples and we had to put 3 extra dots at the ending to show that we have not completely exhausted the multiples of 48. But for factors, the numbers of factors of any number are finite. So as long as you are able to find all the factors, you don't have to end it with 3 dots as we did in the time of multiples. These are all the factors of 48 we have found here. So let's go ahead and try the second example that we have here, 64. And we are going to do that using the same method we've just used right now by breaking it down as product of 2 numbers. So for 64, let's do that a bit higher so that we have more space than the last time. We're going to have 64 equals to, start with 1. 1 times 64. We know that every number is a factor of itself. 1 is a factor of every number. So the first factor will always be 1. And the last factor will be the number itself. So take note of that. First factor will be 1. Last factor will be the number itself. So let's go ahead. After 1, we have 2. We're just going to keep trying these numbers. So this will be 2 times 32. Again, like we did in the previous example, if you didn't already know that, feel free to just try this on the side. We know that 64 times 2. 6 divided by 2 is 3. And 4 divided by 2 is 2. When you don't have a remainder, you know that that is a factor. And then, of course, the result is a factor as well. So after 2, I'm going to try 3. If I do 64 divided by 2 is going to give me 21 remainder 1. Because of this remainder, we know that that's not a factor. So next we're going to try 4. We know that 64 will be 4 times 16. Feel free to try that on the side. Do 64 divided by 4. 6 divided by 4, you're going to get 1 remainder 2, and 24 divided by 4 is going to give you 6. No remainder, you know that that's a factor. The next number is 5. You can clearly see that 60 divided by 5 is going to give you 12 remainder 4. And because of that remainder, 5 is not a factor. You can try 6 as well. 6 is going to give you 10 remainder 4. If you try that, you can also try for 7. 7 is going to give you 9 remainder 1, so it's not a factor. And then you can try 8. If you try 8, 64 divided by 8, of course 64 is a perfect square. You know that is going to give you 8 times 8. And for perfect square, every time you get to their roots, just know that you've exhausted all the factors. There's no need to try and go on. You already know that 9 is not a factor, 10 is not a factor. The next factor you're going to get if you continue going down is 16. And since 16 is already here, then you stop. And then you can go ahead and list these numbers in order as the factors. So we're going to say, so therefore, the factors of 16 are, and then we list just like we did in the first example, 1, 2, 4, 8. There's no point in repeating the 8. Just go ahead and write the rest. We have 16, we have 32, and 64. And these are the factors of 64. Now, one thing I'm going to mention is that when you make a list of your factors, you're mostly going to get an even number of factors, except if that number is a perfect square, then you're going to get an odd number of factors, because you already know that from your list, each of the numbers in your list can multiply themselves. You have 1 and 64. You have 2 and 32. You have 4 and 16. And then in this case, the perfect square, so it's 8 times 8. If it was not a perfect square, you have another number here that could multiply it. So that's how, those are factors of 64, and that's how to find it. I think we have 2 more examples. So let's move on to the next one. To find the factor of 45 using the same method as well. We're going to break it down just like we did, and we'll say 45 is equals to, this is an odd number. Of course, let's do 1 times 45 first. 1 times 45, because 1 is a factor of every number, and every number is a factor of itself. So what I was going to say earlier is that don't bother trying to. It's an odd number. If you say 45 divided by 2, you are definitely going to get a remainder. So let's just go with the next number, which is 3. And we know that 45, we know 3 is a factor of 45. That's going to give us 3 times 15. And like I always said, if you don't know this by heart, feel free to try this number on the side. You can even try 45 divided by 2, but there's no point, it's an odd number. But if you do 45 divided by 3, you find that you're going to get 15. The next number is 4. 4 is an even number. Don't bother with your even numbers when you're dealing with an odd number here. So let's just skip and go to 5. And you know, if you do 45 divided by 5, you're going to get 9. So we're going to say 5 times 9. 6 is our next number. 45 divided by 6, we know that's not going to go through. It's going to give us a remainder. 45 divided by 7 as well will give us a remainder. That's just going to be 6, remainder 3. So there's no point trying 7. 45 divided by 8 will be 5, remainder 5. Remainder there, no point. So the next number will be 9. And like I said, 9 is already here. If I try to write 9 again, it's just going to be 9 times 5. But since we already have 5 times 9, there's no point in repeating that. So we are done. The moment you get to a number or a pair of numbers that is already represented in your list, you can move on. You know you've finished your list. So we're going to say, so therefore, factors of 45 are 1, 3, 5, 9, 15, and 45 itself. So these are the list of factors of 45. And like I was saying, 1 times 45, 3 times 15, 5 times 9, an even number of factors. So those are all the factors of 45, and that's how to easily list all the factors of a whole number. And for our final example, we have 81. To list the factors of 81 in the same way we've done for the rest, we're going to say that 81 is equals to 1 times 81. Like I said, when you see an odd number, don't bother trying to, just move on and try the next odd number. So 81 divided by 3 is going to give us 27. You can try that if you want. So we are going to say 3 times 27. Simple, just say 81 divided by 3. 8 divided by 3 is going to be 2 times remainder 2. So 21 by 3 will give 27. So that's it. Again, I'm not going to try 4. It's not a factor. If I go with 5, it's going to be remainder as well. The same will happen for 6, 7, and 8. So I'm not going to be trying that. The next number that will be a factor of 81 here will be 9. And of course, if you already know your perfect squares, you know that 81 is a perfect square. And that's going to be 9 times 9, which already means that this is where we are going to stop as far as factors of 81 are concerned. There are no other factors. If you continue to try other numbers from 10, 11, 12, 13, you're not going to find another factor until you get to 27. So there's no point repeating 27 times 3, because 3 times 27 is already here. So let's go ahead and make our list by saying, so therefore, the factors of 81 are 1, 3, 9, 27, and 81. So that's it, guys, on factors and how to find factors of whole number. As always, I've got an assignment here for you to do. Find the factors of the following numbers. We have 21, 25, 36, and 60. Use the same method and see if you'll be able to list all the factors of the given numbers there. I hope you enjoyed today's lesson. Please check out our next lesson on common factors. Thank you guys for watching. Do well to like our video, share, subscribe, and turn on our notification bell so you will know when we upload a new video. I'll see you in the next one. Bye.